Okay guys, so today we're going to be working on something called proofs. Now proofs are not the easiest thing in the world to do, so I'm going to try to go through it step at a time and try to tell you in a way that's going to make sense. But you really got to pay attention to be able to do these, okay? And they're a big thing in just geometry, okay? So first of all, we're doing what's called a two-column proof. We've got two columns. One column is going to be our statement, and the second column is going to be our reason. So in our statements, you're going to say things like angle K is congruent to angle M, or triangle JKL is congruent to triangle PQL, or something like that. All right. So those are our statements, and our reasons are going to be the way we know those things. So it might be something is given to us. Maybe the reason we know that is because they told us that in the directions. So we'll say it was given, or maybe another thing we might figure out something because vertical angles are congruent. So that might be a reason that we say, okay? Or maybe it might be SAS, the property SAS, we know something, okay? So it's always going to be what we know, okay? So you can think of statements as what we know, and then the reasons are how we know the thing that we know, all right? So let's go ahead and practice one of these. Well, first of all, let's talk about some more properties that we need to know. One thing is the reflexive property, okay? So essentially the reflexive property is something like AB. All right, so let's say that this is A right here, and this is point B. So the reflexive property would be something like AB is congruent to AB. If we wanted to use that as one of our reasons, okay, or our statements, we know AB is congruent to AB, then the reason would be because of the reflexive property. The reflexive property just tells us that something equals itself, or something is congruent to itself. Now symmetric property is kind of a flip of that. So it would be like saying AB is congruent to BA. Alright, so AB is congruent to BA. Notice you just switch the letters around, but it essentially is the same thing. In vertical angles, of course, anytime we have two angles across from each other, those are vertical angles. So that might be the reason that we say something, that there's two vertical angles. Okay, and then definition of a midpoint is going to be like a situation where maybe they give us a point right here and they tell us these two are the same. So we know these two are the same because they told us this was the midpoint. Maybe they say A is the midpoint of this line. So because A is the midpoint, we could say, oh, well, BA point or line segment BA equals or is congruent to segment CA because the definition of a midpoint tells us these two are the same. So that's one thing that we could use. And then definition of a bisector. So let's say we have an angle and they tell us that this is a bisector. So maybe AB, they tell us in the directions that AB is a bisector of this angle. So we could say, all right, well, this angle and this angle are congruent because the definition of a bisector tells us that it splits the angle in half. All right. So those are just some things that we might use here on some of these problems. All right, so let's review reflexive and symmetrical quick. I'm going to pause it. I just want you guys to write each of these under the column either for reflexive property. Okay, I'll just slide them over, but you guys need to write each one of these either under reflexive property or symmetric property as to which one you think it is an example of. I'm going to go ahead and pause it. Just put those in place. All right, so hopefully this is what you guys got. Hopefully you saw that. Hopefully you saw that these three were reflexive and that these three over here were symmetric because the letters switched places. Alright, so now, what is given? We talked about that a little bit. A given, okay, is something that is already marked on the triangles or something that they tell you in words. Okay, so those things are given, things that are given to you. Okay, so right here, let's just practice a little bit with doing one of these actual proofs, okay? So I'm going to give you all the statements instead of having you think of them at first, and we'll just put them in their place, and then we'll practice with some later where you actually have to come up with the statements on your own. Okay, so the first things you're always going to put in your columns, okay? They're always going to be your given, things that they give you to start with. So let's look right here first and see what is it that they give me to start with. What do I know right off the bat? Well, I can see the side JL is congruent to the side NL. Alright, so that's something I'm given. So let's see here. Oh, there it is. JL is congruent to NL. I might need to group this real quick so that it'll all come together. So maybe you can learn a little computer skills here if you didn't already know that. Alright, so we're going to say JL is congruent to NL. And what's the reason we know that? That's what we know. What's the reason we know it? Oh, well, it's because it was given to us. We were given that right off the bat. We knew that was going to be true. Alright, so let's look at another thing we know. We know KL is congruent to ML. So that's right here. KL congruent to ML. And again, that was given to us. So we say given for our reason. Alright, so what else do we know? Well, we know just by looking at the picture and just learning things we've learned in the past, right? We know that this angle is congruent to this angle because they're vertical angles, right? So what would our statement be? Our statement would be that angle JLK is congruent to angle NLK, or sorry, NLM. So right here is our statement. And the reason we know that is because we know that vertical angles are congruent. Alright? Then the last thing is we can see, oh, well, side angle side, side angle side. So our statement right here is this right here, that triangle KJL is congruent to triangle MNL. Now, one thing that we also know, we always start off with the givens. We always end, our last statement is always the thing we're trying to prove. They want us to prove this. So that is always going to be our last statement. Okay, and the way we know they're congruent is because side angle side. So we'd say our last reason, side angle side. All right, let's do another one. Alright, so on this one, start with your givens. What are we given? We're given AD is congruent to AB. So we're going to put that as our first statement, and we're going to say the reason is that it was given. DC is also congruent to BC. So we'll put that there, and we know that because it was given. Okay, what else do we know? Well, we know that this side, of course, is the same as itself. So we could put these markings for AD and AB, and then DC congruent to BC. Okay, but we also know AC is congruent to itself. Alright, so if we're going to say AC is congruent to itself, we would use this for our statement. That's something else that we know. We weren't given that, though. We had to determine that on our own. Well, how do we know that? We knew that because of the reflexive property. The reflexive property just tells us something is congruent to itself. So that's the reason we knew that. That's where the reflexive property will come in. And last thing is always going to be the thing we're trying to prove. We're trying to prove, okay, because they told us in the directions, prove this. That's always going to be our statement on the left, on our very last statement, the bottom left. And the reason we know is because side, side, side. They've got three sides congruent with each triangle. Alright. Okay, let's do another one. So what are we given here? We're given AC is congruent to EC. Alright, so sometimes they'll give you things in words, and sometimes they'll give it to you in picture. Last one, we just had the words. We didn't have the picture. But this one, they give it to us as both. So AC is congruent to EC. That's a given. BC is congruent to DC. And that is also given. Then what else do we know? Well, like one we did earlier, okay, we know that these two angles are congruent because they are vertical angles. So that's angle ACB is congruent to angle ECB. So that would be our next statement we would use, angle ECD. Oh goodness, let's group it again. We know that angle ECD is congruent to angle ACB because vertical angles are always congruent. And then last thing is what we're trying to prove is our last statement, always. And how do we know that? Because side, angle, side. So it'll be SAS. Alright, so I'm going to go and pause it and let you guys try this one real quick, and then we'll talk about it. Okay, so we know that we're given JK is congruent to NK, so we put that in with it as a reason it's given. Also, A is the midpoint of JN was given, so that's there, and given's in there for our reason. Now, we also, because A is a midpoint, because of the property of a midpoint, okay, we know that AJ must be congruent to AN. Those two segments got to be the same. If A is in the very middle, it cuts it in half, so those two got to be the same. So we can say AJ is congruent to AN because of the property of a midpoint, and then we can say that AK is congruent to itself because of the reflexive property. Something is always equal to itself. Alright, so then once we know all that, we can say, okay, well, our triangles are congruent because of side-side-side congruency. Alright, now next one, we're going to give you some extra things here. You notice there's only 8 blanks, but we've got a lot more than 8 options here, so it'll make it a little bit tougher. But we always, again, start with our givens, no matter how many things we know. So what are we given? Angle Q is congruent to angle S, so we can put that in for our statement and say that it is given. Also, angle TRS is congruent to angle RTQ. We know that because it's given. Well, what else do we know? Well, we can tell that these two triangles share a side. Because they share a side, we can say that this is congruent to itself. So that would be TR or RT. So TR is congruent to RT. Now notice that this time we swap the letters. Okay, we swap the letters. So this is not the reflexive property. This is the symmetric property. And the time you swap the letters, you say, well, how do I know when to swap and when not to? Whenever you use them differently for each triangle. So right here, if I go from R up here for the right triangle, I go from the angle that has 2 marks to the angle that doesn't have any, so I'm going from R to T. But if I go from the angle that has 2 marks to the angle that doesn't have any on the left triangle, I have to go from T to R. So that's why you would say this time RT is congruent to TR. Alright, so that's why you would swap them in this situation, because in this triangle R has the 2 marks and this one T has the 2 marks. Alright, and then the last thing we need, so right here we can see once we make that tick mark, we can see we've got angle, angle, side. Alright, so we would use angle, angle, side for our reason, and of course the left bottom box is always going to be what we're trying to prove. Triangle RTQ is congruent to triangle TRS. And we're done. Alright, so you guys go ahead and try this one. It's a little bit tough. Notice right here, these arrows mean that these two lines are parallel. But I think you guys are smart. Give it a try and I'll go over it. Alright, so on this one, again, we start with our givens. And the things that we are given are that PQ is parallel to RS. That's what we're given, so we put that in here, given. And we also PRQ is congruent to angle SQR, so that's given. Now, one thing that we know is we know that this line is congruent to itself. RQ is congruent to RQ because of the reflexive property. And now, because these lines are parallel, this was the tricky part. Because these two lines are parallel, we've got to remember that this angle is going to be congruent to this angle because they are alternate interior angles. Right? They're on the inside of the two parallel lines, they're in between the two parallel lines, and they're on alternate sides of the transversal, the line cutting them in half, or cutting them into pieces. So they're on opposite sides, or alternate sides. So they're alternate interior angles, and we know that alternate interior angles are always congruent. So we can say angle SRQ is congruent to angle PQR because they're alternate interior angles. So then once we know that, we can say, oh, well, we've got angle, side, angle. And right here, angle, side, angle. So our triangles are congruent because of angle, side, angle. Alright, now it's finally time to do some without being given the reasons to start with. Alright, so this is where the rubber meets the road. Do you really know it or not? Okay, so we always start with givens. So I know this first box is always going to be a given. At least one thing is going to be given to us, most likely 2 or even 3. So what are we given? We're given that angle NER is congruent to angle NVR. And sorry if my writing gets a little confusing. That's why you might want to listen instead of just watching. Alright, so that's given, and we were given a second thing. We are given that RN bisects, that means cuts in half, angle ERV. Right, so because that bisects the angle, okay, if RN bisects this angle, we know that this part of the angle and this part of the angle must be congruent. Okay, so that's a new statement that we can make. We can say that angle ERN must be congruent to angle VRN. Angle ERN is congruent to angle VRN. How do we know that? We know that because of the property of a bisector. We know that a bisector is going to cut the angle in half, so we know those two angles got to be equal. Alright, so what else do we know? Well, we know that this side is going to be congruent to itself. Okay, so we can say RN is congruent to RN. And we know we don't need to switch the letters because in both triangles we're going from the angle that has 2 marks to the angle that doesn't have any. So it's going to be the same. So RN equals RN, and that again is the reflexive property. Whenever something is equal to itself. Reflexive property. And then the last thing, we know by looking at the triangle, angle, side. That's one of our properties that tells two triangles are congruent. So our statement is going to be what we're trying to prove. Triangle ENR is congruent to triangle VNR. How do we know that? Because angle, side. Two angles, and then the other side is congruent. Alright, so you guys go ahead, pause it, and try this one, and we'll go over it. Alright, so hopefully you guys did alright on this one. So let's start with what we're given. Only thing we're given is that TR and MN bisect each other. So that's what we would put for our statement, and it's something that was given to us. That's how we know. Now, what does that tell us, though? So if something bisects, remember it cuts it in half. So if they bisect each other, if this line and this line bisect each other, then I know they both got cut in half. So NP must equal PM, or MP, and TP must equal RP, or be congruent to. So that gives us new information. So now we can make some more statements. We can say TP is congruent to RP because of the property of a bisector. It cuts it in half. Same thing, NP must be congruent to MP because of the property of a bisector. It got cut in half also. So then from there, what else do we know? Well, we also know this angle is congruent to that angle. How do we know that? Because they're vertical angles, right? So we would say angle NPT, right? Angle NPT is congruent to angle MPR. Why MPR, not RPM? Because we start with N and go NPT. We started with the side that had 1 mark. So we got to start with the side with 1 mark down here also. MPR. So NPT is congruent to angle MPR. Our reason, because vertical angles are always congruent. So then once we have all our marks, we can see, oh, this is side, angle, side. Side, angle, side. So we're done. We can prove they're congruent now. So we can write our congruent statement for the triangles and say they're congruent because of SAS. Alright, well, hope you guys enjoyed the video. I know this isn't real simple, right? But you know, it's something that's going to take a lot of practice, and you guys, you know, just gotta do them over and over and over again, and they'll get a lot easier as you do them, and it'll make more sense. Okay, so time to practice. Appreciate your time. Love you guys. Have a good day.